Alright, problem 34 says to evaluate each expression. So essentially what's taking place is I'm plugging in these values as they relate in the expression. I is -4, so -4. R equals 6. T equals -3. Right off the bat, I notice I have two negative numbers, which will multiply together to give me a positive number, and a third number that's positive. So my solution will be positive. 4 times 6 times 3 is 72. Number 35, we have 8m. M is valued at 3, so we have 8 times 3, which is 24, plus 5 times n. N is valued at -2. 5 times -2 is -10, minus 3. 24 minus 10 minus 3 equals 11. Zoom out again so you can see some of these word problems. Grace spends $15.25 on supplies to make lemonade. At least how many glasses of lemonade must she sell at 45 cents per glass to make a profit? So at 0.45 per glass X, that value needs to be greater than 15.25. When we divide both sides by 0.45, we find that X has got to be greater than 33.88. Since you can't sell 0.88 of a glass, we know that X has got to be greater than, or now can be equal to, 34, because our 34 is greater than 33.88. So 34 can be an included value. We would change our inequality sign to greater than or equal to. Mrs. Meag has promised her two sons that they may go to a concert if they save more than $45. The older son agrees to save twice as much as the younger son. So the older son is represented by twice as much as the younger son, plus the amount the younger son saves is X, because we don't know how much that is yet. And that amount needs to be greater than $45. 2x plus x is 3x. It's got to be greater than $45. Divide both sides by 3. X has got to be greater than $45. Now, X represents the amount of one son, the younger son. So now the older son must save, not $45, $15. I was wondering why that problem was looking awfully funny. The older son must save $30 to have twice as much as the younger. Carlos can spend $125 at Best Buy. In his cart, he has movies that each cost $17. What is the number of movies he can buy without exceeding his limit? So he can buy movies at $17 each, or 17 times X. And 17 times X can be less than or equal to $125. He just cannot exceed $125. So when we divide by 17 on both sides, we find that X can be less than or equal to 7.35. Again, since you cannot buy 0.35 of a movie, we know that the maximum number of movies without exceeding his set amount would be the whole number value, so he can buy 7 movies. Miss Mullis and Miss Wiles ride bikes each day for exercise. Miss Wiles rides twice as far as Miss Mullis each day. So if we assume that Miss Mullis rides X, Miss Wiles would ride 2X. If together they ride 15 miles, so that value equals 15, how far does Miss Wiles ride? X plus 2X is 3X. Equals 15. Divide by 3. So my X equals 5. Now X equals 5 is only my solution for X, and X we use to represent how much Miss Mullis traveled each day. Miss Wiles traveled 2 times X, so 2 times X would be the same as 2 times 5, which equals 10 miles each day. And the last problem on this page, an amusement park charges $5 for admission, $1.25 per ride. You go to the park with $25, write an inequality that represents the possible number of rides you can go on. What is the maximum number of rides you can go on? Well, first we need an inequality statement. So we have the cost for ride is 1.25 per ride, means I'm getting multiplied by however many rides I go on. I don't know how many yet, which is why we use the variable X. And then it costs $5 for admission. It doesn't cost $5 for admission for each ride, just $5 for admission into the park, and then I pay per ride. And that value has to be less than or equal to $25, because that's how much I've been given to go to the park with. So now I subtract $5 from both sides. 1.25 has got to be less than or equal to $20. Oh, sorry, 1.25x. When we divide by 1.25 from both sides, we determine that X has got to be less than or equal to 16. So 16 would represent the maximum number of rides that I could go on. And our inequality that represents this maximum number of rides is what we started out with and already solved.